So we're going to basically be focusing on uses of integration or applications of integration. And we've mentioned before that one application is to find the area under a curve. And we've talked about the simple situation where if you've got some curve y equals fx, where f of x is positive, and you're trying to take it from some straight line, x equals a, and some other straight line, x equals b. You're trying to find that area here. Then we say that the area is the integral from a to b of f of x dx. Now, we've also talked about something similar. And the other very similar one, of course, is just the y version, which is, again, find the area not so much under a curve, but to the left of a curve. But in this situation here, we would need it to be between y equals a and y equals b. We need it to be x equals f of y. Now, in this situation, we need f of y to be positive. All right. And then in that situation, your area must equal the integral from a to b of f of y dy. Okay, all of that we've covered before. No questions with any of that, right?
No.
Good. All right. So you might remember that we said that f of x has to be positive. So in other words, it has to be above, and x equals f of y, this has to be to the right on over here. So I guess the first question we might want to think about is, well, what if it's not above? So let's stick with y equals f of x for the moment. And let's think of a situation where it isn't above. Okay. Any ideas what to do in this situation where it's below? Everything is the same except f of x is below the x-axis.
Well, can you just do the same thing?
Well, you could definitely do this. You could definitely find the integral of a to b of f of x dx. But if we do that, we're going to find that this answer is negative. So let me give you an example. So let's say that we've got negative x squared. And let's say I've got from 0 to 1, keeping the numbers simple. So if I do the integral of negative x squared dx from 0 to 1, you'll find it's negative a third x cubed, 1, 0. So in other words, we're saying find this area, green. And as a tip, because it's a constant, you can just take that out. So it's 1 cubed minus 0 cubed, which is just 1, leaving you with negative a third. Now, can that be the area?
No.
No, because it's negative. And area is always
Positive.
right. So we could definitely do the integral. There's no problem doing the integral, but we get an answer that in some ways we might think doesn't make sense. Any ideas what we would do?
Can you make the function negative?
Oh, basically, yeah, essentially, right? So it doesn't matter how you really want to think about it. I could explain it sort of in the sort of very fundamental way with, you know, what integration means, but, you know, you could go and review that, and it actually comes from that definition. But I found that confused you a bit, so maybe you can think about it a different way. But basically, look, if we do this integral, it will be negative, yeah?
Mm.
As we've demonstrated here. Now, the point is the number is correct. So the sign is wrong, but the number is correct. Does that make sense?
Mm-hmm.
So the area is basically a third, is what I'm saying.
Mm.
So we can either think of this, you know, you can either think of it as we'll just do the integral, but then take the negative of it, because this thing is negative. Or if you are comfortable with absolute value signs, you can also just think of it as is the absolute value.
Okay.
So if it's positive, doesn't matter. If it's negative, doesn't matter. As long as, you know, it's all negative or all positive, yeah?
Mm.
And so the other thing we want to kind of, maybe you could think about it as, depends on if this helps, we're basically taking the negative of the function, we're flipping it up, and then finding the area. It's a mirror image, right? Because if I made the negative x squared positive x squared, then this would still be the same area, yeah?
Yeah.
So we can just take the negative of that and then integrate it. All right. So the key point right now is, if you've got an area which is above the x-axis like this, then of course the area equals the integral from a to b of f of x dx. Now, if it's below the x-axis like this, and we want to find the area, then you can either think of it as the absolute value of integral from a to b of f of x dx, or the negative of the integral of a to b of f of x dx. But what's important for you to recognize is that the integral itself, when it's under, is negative. Makes sense?
Makes sense.
And of course, the analogous versions are, if it's to the right, then area equals the integral from a to b of f of y dy. And of course, if it's to the left, then the area must equal the absolute value of the integral from a to b of f of y dy, which must equal the negative of a to b of f of y dy. Does that make sense?
Yeah.
Okay. So that hopefully is fairly straightforward. If it's above or to the right, then it's positive. If it's below or to the left, then it's negative, and you need to adjust accordingly. So just quickly then, let's say I've got this function. And assume this is to scale. This is 0, a, b, c, d, e. What can you tell me about the integral from 0 to a of f of x dx?
It's positive.
Correct. A to b,
Negative.
c to d, b to c,
Positive.
c to d,
Negative.
d to e. Very good. All right. Now, let us now do questions which might not be quite as obvious. What about b to d?
Mm. Positive.
Why?
I don't know. I just feel like it's positive.
But why do you say that?
Mm.
I mean, is it a pure guess, in which case you got a 50-50 chance of getting it right? Unless it's 0, of course. Or are you saying that for a particular reason?
Not really. Well, I feel like B to C is. But actually, never mind. No.
No, keep going. You feel like, yeah, keep going.
I feel like The positive part is bigger.
Yeah, no, exactly, right? This area, like you remember just comparing numbers, right? So B to D would have this positive part, but it will also have this negative part. But this positive half is bigger, so this overall would be positive, right?
Oh, also I will try.
Yeah, because remember, like this part is, B to C is about the area, right? C to D is kind of the area, but it's negative. But the negative number is smaller than the positive number because the area is bigger.
Yeah.
Yeah?
Mm-hmm.
What about C to E?
Positive.
For the same reason, right?
Yeah.
What about A to C?
Positive. Oh, negative.
Yeah. What about 0 to B?
Positive.
Right. Does that make sense?
Mm-hmm.
All right. So that's true. Now you need to understand that when I do, like, for example, B to D in my example here, I'm going to have this positive number minus this negative number, and whatever the result is, I'm going to get that number, right?
Yeah.
Which would ultimately be positive. But now what if my question is, I want you to find the area, like the shaded area in yellow.
Then it's positive.
Well, that's not the question. I mean, obviously it's positive because it's area, but my question is, how would I find the area that's shaded in yellow?
You find B to C and you find C to D and add them.
Yeah, you would need to separate them, okay? So you can't just do B to D, that won't work.
Yeah.
You would have to do B to C and work out what that area is. You'd have to do C to D and work out that area is. Whether you want to use, a negative or an absolute value, doesn't matter. But the fact is you have to separate the areas out, okay? You know how to find areas above. You know how to find areas below. You don't know how to find areas above and below together, right?
Yeah.
So yes, to find the area of, let me minimize this a bit. But yes, if we were to try to find the area of, too much. If we were trying to find the area shaded in yellow, we would have to basically take the integral from B to C of f of x dx. And then we would need to let me do it another way. It's basically area 1 plus area 2. And area 1 would be represented by the integral from B to C of f of x dx. And area 2 could either be represented, well, it's going to be related to the integral from C to D of f of x dx. And whether you choose to use absolute value, like I'll choose to do here, or make that negative is up to you. But the fact is you've got to make that an area. Yeah. And essentially just need to take away the negative side. All right. Happy with all of that?
Yeah.
All right. So now let's consider so-called more complicated areas. It's not that complicated, but compared to before, it's more complicated. Specifically, they are bounded by two functions. So I'm going to have one function, y equals f of x. I'm going to have another function, y equals g of x. And I'm going to make it so that they look like this. They're both above the x-axis for now. As usual, left boundary is A, right boundary is B. How do I find this area?
You find the area of fx and you find the area of gx and minus.
Yeah, exactly. So conceptually, this shaded area equals just the area, let's call it the green one, minus the blue one. Yeah?
Mm-hmm.
Both of which you know how to work out, right? Because that's just the integral from a to b of f of x dx minus the integral of a to b of g of x dx. And because A and B are the same, you can actually put them together. Does that make sense?
Mm-hmm.
Good. So yeah, as long as you can apply that sort of idea, then that's fine. So this sort of concept then applies to both your y as well. So obviously, we're saying then that if you've got some top function y equals f of x and some bottom function y equals g of x, and you're bounded on the left and right by x equals a and x equals b, then this area here is simply going to be the integral from a to b of f of x minus g of x, where f of x is simply going to be the top and the g of x is simply going to be the bottom. The y version is very similar. We're going to have x equals f of y, x equals g of y. You have two boundaries, one at the top and one at the bottom, a and b. And you have this sort of area here. And very similarly, our area there will be the integral from a to b of f of y minus g of y dy. And that becomes, in this case, your right minus your left. Does that make sense? All right, so I've kept things simple for now, and I've kept both f of x and g of x above the x-axis in my left-hand side example. My question now is, does it matter if they're both above the x-axis? So for example, what if fx is above and g of x is below? Or what if they're both below? Doesn't matter. Why not?
I mean, it's the absolute value, so they're positive anyway.
Well, we haven't said it's the absolute value the way we've done it, right? There's no absolute value here for now.
But you're finding the area.
Yeah, but I've expressed it as an integral, you know?
Oh, okay.
So, you know, will it give you the right answer is what I'm saying.
Wait, can you draw it? What do you mean when it's like negative?
Yep, so that's what I'm about to do. So, for example, what if I had this situation? And I wanted to find this area.
Oh, compared to the one on the previous page.
Well, I mean, it's still the same idea, right? fx is on the top, gx is on the bottom, except in my case here, before both fx and gx were above, right? The x-axis. Now I've put gx below. And then, you know, there's another situation where, for example, you know, fx and gx are both below. fx, as far as I'm concerned, is always the one on the top. Gx, as far as I'm concerned, is always the one on the bottom. But depending on where they are, will this change anything?
Well, maybe it will become negative then.
Well, let's think about it. If we want to find the area, we want this, you know, blue area, area 1, and we want this red area, area 2, and we want to add them, right? So the black area is going to equal area 1 plus area 2. Agreed? All right, so let's work these out separately. Area 1 is what?
Fx.
Well, the integral from a to b of f of x dx. It's not fx, but it's the integral from a to b of f of x dx. All right, so that's area 1. That's easy enough. What is area 2?
The same, but with gx.
Exactly the same?
It's negative.
Yeah, it's negative. Because it's under the x-axis, right?
Hmm.
Which means plus negative means it's minus. And well, in that case then, that just means it's going to be fx minus gx. Is this different or the same as before?
You can go back. Different.
Huh? How's it different?
Wait, go back. Go the other thing. Oh, the same.
Yeah, it's the same.
Mm.
So it didn't make a difference, right? It's still the top minus the bottom. Understood?
Yeah.
Do you think it'll make a difference here?
But it's the bottom minus the bottom.
Well, so right now, in this case, we will want to get, for example, you know, the yellow area, right? So now we want the yellow area minus the green area, right? Agreed?
Yeah.
So our area will now be the yellow area minus the green area. Like, you know, fundamentally you agree with that, right? That's how we would work it out, yeah?
Yeah.
All right, so what is the yellow area? How do we work out the yellow area?
It's the integral of gx from a to b.
Is that all?
And it's negative.
So that's the yellow area, yes?
Yes.
What about the green area?
It's positive integral of f. Wait, no, it's negative. It's negative. Yes, same by fx.
And we take away these areas from each other, right?
Hmm?
And so, you know, this is the yellow area in brackets, and this is the green area in brackets, yeah? And we need to take them away from each other, which then means you've got the negative of the integral of g of x dx plus the integral of a to b of f of x dx. And you're back to square one again. Does that make sense?
Oh, you can just bring the negative back.
Well, we're subtracting a negative, right? So minus minus is plus.
Oh, yeah.
And you know, like negative b plus a is a minus b, you know?
Yeah. Oh, wow. Okay.
Does that make sense?
Mm.
So what I'm trying to show you here is, if we're thinking about it in this sort of top minus bottom way, then it doesn't matter anymore.
Yeah.
As long as you've taken the top function minus the bottom function, it will always work. You know, in a situation. Doesn't matter where fx and gx are, as long as it's top minus bottom. Or if you're doing it this way, as long as it's right minus left.
Mm-hmm.
And in fact, let's go back and think about this sort of question, the one we did earlier. So you've got an area like this. We know the answer is going to be the negative of the integral, right? We know the area is just going to equal the negative of the integral of a to b of f of x dx. That's what we expect, right? But let's not think about that. Let's ignore that for now. Can I think of this as being bounded by a top and bottom?
Sure.
What's at the top? What's the boundary at the top?
The curve.
Is it at the top? Is the curve at the top?
No, the x-axis.
What do we call that? What function is that?
Y equals to 0.
Yeah, and your bottom is y equals fx, right?
Yeah.
So if you think of it as the integral from a to b of top minus bottom, then it'll be the integral from a to b of 0 minus f of x dx, which is just the negative of the integral of f of x dx.
Yeah.
So can you see that as long as even this rule can be derived from just understanding that it's the top is 0 and the bottom is your f of x.
Yeah.
Does that make sense?
Mhm.
Good. So that's basically areas covered, but you're not having any trouble with that, right?
No.
Good. In that case, I'm now going to cover different applications. So what other applications are there? And we'll start with kinematics. So basically, for every virtually for every derivative one, there's an equivalent analogous integration one.